Parent functions and transformations. Our goal is to identify the effect on the graph of the function by replacing f of x by f of x plus k, or k times f of x, or f of k times x, or f of x plus k for a specific value of k, both positive and negative. And we will be able to find the value of k given the graph. So we'll be looking at parent functions, transformations, translations, and dilations. A family of functions is a group of functions with the graphs that display one or more similar characteristics. The parent function is the simplest function with the defining characteristic of the family. Functions in the same family are transformations of their parent functions. So first parent function we are going to look at is f of x equals c, which is a constant function, f of x equals c, where it can be f of x equals 2, f of x equals -5, or f of x equals 0. F of x is same thing as y, so it's like y equal to 2, or y equal to -5, or y equal to 0. It is going to be a constant function, horizontal line. The domain is all real numbers, and range is just the number c, y value. It's only that number c, whatever constant is on the right hand side. Next parent function we're going to look at is a linear function, which is f of x equals x, or y equal to x. It's a straight line at an angle 45 degrees, or slope of the line is 1, and y-intercept is 0. So this is a line y is equal to mx plus b form, where slope is 1 and horizontal y-intercept is 0. Domain in this case is all real numbers, and range is also all real numbers. Next parent function we are going to look at is quadratic function. Simplest form is f of x equals x squared, or y equal to x squared. Domain is all real numbers, and range is 0 to infinity. It does not go below x's, and the smallest y value it takes is y equal to 0, and bracket around 0 because that's a part of the domain. That's a part of the range for the function. If the function is shifted, translated, then it can go below x-axis as well. But y equals x squared stays on x-axis and above. Next parent function we're going to look at is square root function, which is f of x equals square root of x, or y equal to square root of x. Remember, for the even root, we can only have positive radicands for the even roots. So only positive values are allowed inside the square root or fourth root or any even root function. So this function, graph of this function is going to be on the positive x-axis only. Domain is 0 to infinity, and range is also 0 to infinity, both including the 0. Next basic parent function we're going to look at is the reciprocal function, or this is also called the rational function. Reciprocal function or the rational function. F of x is equal to 1 over x, or y equals 1 over x. So the graph of function is given here, and this function has a horizontal asymptote at y equal to 0, and it has a vertical asymptote at x equal to 0. So there's a horizontal asymptote and vertical asymptote. Horizontal asymptote is the end behavior of the graph, when x becomes really, really large. What values are we approaching as x becomes really, really large? What y value are we approaching? Vertical asymptote is what x value are we approaching when y becomes really, really large. In this case, when y becomes really large positive or really large negative, we are approaching x equal to 0. Same thing when x becomes really large positive or negative, we are approaching y equal to 0. Next is absolute value function. graph looks like a letter V, and absolute value function is a piecewise defined function. Absolute value of x is equal to itself if x is greater than or equal to 0. Its opposite of x if x is less than 0. Domain is all real numbers. Range is 0 to infinity only. Next, we have greatest integer function. The graph, it is also called a step function. Step function. So the graph of greatest integer function will have a closed dot at the starting point and a hole at the end point, and the graph looks like a staircase. That's why it's called a step function. Domain is negative infinity to infinity, and range is all real numbers. Now we're going to talk about transformations. There's rigid transformations and then there's non-rigid transformations. Rigid transformations change only the position of the graph, leaving the size and shape unchanged. So rigid transformations will shift the graph from one place to another on the coordinate plane, but it will not change the size or shape of the graph. Non-rigid transformations, on the other hand, distort the shape of the graph as well. Rigid transformations, first of all, we're going to look at vertical translations. If we add a number after the function or subtract the number after the function, that's going to shift our graph that a units up or down. For example, if my parent function is y equal to x squared and I do x squared plus 3, this second graph will be shifted 3 units up from the parent function. And if I do y is equal to x squared minus 3, if I subtracted 3, then that would be shifted 3 units down. Horizontal translations. If the number is actually inside your function, added or subtracted. Notice it's not after your function, it's not after f of x. Now this number is an intruder, it's going inside the function. So if it's f of x minus b, graph will be shifted b units right. If it's f of x plus b, graph will be shifted b units left. For example, if my parent function is x squared and I have another graph which is y is equal to x minus 3 squared. If I have a negative inside, so that graph will be shifted 3 units to the right. If it was y is equal to x plus 3 squared, 3 units left from the basic parent function, which is your basic x squared quadratic function. Rigid transformations. So if there's a negative in front of f of x, that's going to be reflected over x-axis. My graph will be reflected over x-axis. For example, y equals x squared. And if I have y is equal to negative x squared, that graph will be reflected over x-axis. So negative in front of the function reflects the graph over x-axis. Negative inside the function, if I put the negative inside the function, then that's going to reflect the graph over y-axis. So putting the negative inside the function will reflect the graph over y-axis. Non-rigid transformations, these are vertical dilations. Non-rigid transformations actually distort the shape and size of the graph. So if we have a number c multiplied in front of my function f of x and c is greater than 1, then my graph will be expanded vertically. If c is between 0 and 1, then the graph will be compressed vertically. Okay. If number d is inside the function, it's not in the front of the function multiplied in front of the function, it's actually multiplied to the x inside my function, then if d is greater than 0, we have compressed horizontally graph. If d lies between 0 and 1, we have horizontally expanded graph. Identify the parent function and describe the transformation. So f of x equals x minus 1 squared. The parent function is x squared, and transformation is, or translation is shifted 1 unit to the right. Parent function here is x to the third power, and it is shifted 5 units down. If we had x minus 5 to the third, this would have been shifted 5 units to the right. Next graph is an absolute value function. That's my parent function. It is shifted 4 units to the left, reflection over x-axis because of negative. 3x squared plus 7. This graph has a parent function, x squared. It's expanded vertically by a factor of 3 and moved 7 units up. Given the parent function and a description of the transformation, write the equation of transformed function. Quadratic, expanded horizontally by a factor of 2, translated 7 units up. So that would be 1/2 x squared plus 7. f of x equals 1/2 x squared plus 7. Now we have a cubic graph reflected over x-axis and translated 9 units down. So cubic graph reflected over x-axis, which is going to be negative x to the third, translated 9 units down. So negative x to the third minus 9. Next we have absolute value function translated 3 units up and 8 units right. That would be f of x equals 3 units up and 8 units right. That would be our equation of the function. Next, we have reciprocal function translated 1 unit up. So that would be f of x is equal to 1 over x plus 1. The rational function translated 1 unit up. Use the graph of parent function to graph each function. Find the domain and range of the new function. So for this graph, we have a basic parent function. Parent function is going to be x squared, and it's shifted 3 units to the right, 2 units down, and stretched by a factor of 2. So x squared compressed horizontally by a factor of 2, translated 2 units down and 3 units to the right. So my basic parent function, which is y is equal to x squared, is going to be shifted 2 units down, 3 units right, and compressed by a factor of 2. Use the graph of parent function to graph each function. Here we have a square root function. So our basic square root function looks like this, and we will be shifting it 3 units up, 5 units right. 5 units right, 3 units up. So every single point will be moved 5 units right, 3 units up, and this is how our new graph will look like. The red graph, or I actually made it blue now. The pink graph will be our new graph. Domain for this one will be 5 to infinity, and range will be 3 to infinity. Domain is all the x values, input values, and range is all the output values. Use the graph of the parent function to graph each function. So here my basic parent function is absolute value of x, and the graph of absolute value of x looks like this. So here we have reflection over x-axis. We have moved 1 unit down, and we have our graph shifted 4 units to the left. So reflection over x-axis, moved 1 unit down, shifted 4 units left. And this is how the red graph will be our new graph. Domain and range will change as your graph is shifted. Domain will be still all real numbers, but range will be negative infinity to -1. It will not go above -1. Graphing a piecewise defined function. So a piecewise defined function, we have f of x equals negative x to the third. If x is less than 0, it's equal to 3. For between 0 and 1, it's 2x squared minus 2x greater than equal to 1. So we need to graph this function, and it's 3 different ways it behaves. For x less than 0, it's a cube root function reflected. Between 0 and 1, we have a constant function, which is y equals 3. To the right of 1, we have a quadratic function multiplied by a factor of 2, and it's moved 2 units down. So to the left of 0, we have cubic function, and it is reflected over x-axis. And notice we have a hole here because there's no equal sign in here. Between 0 to 1, there is equal sign at 0. So I'm going to have no hole here, but at 1, there is going to be a hole because there's no equal sign here for x less than 1. For x greater than equal to 1, we can plug the points in to create the graph. So when x is 1, what is y going to equal? Y will be 2 times 1 square minus 2, which is 2 minus 2, 0. And when x is 2, y will be 2 times 2 square minus 2, which is 2 square is 4 times 2 is 8 minus 2 is 6. So we can see how the graph is going to be a parabola going upwards. That's all for the basic parent functions and transformations.